Okay, good afternoon, everybody. Thanks, Brian, for the introduction. Well, the topic of my presentation today is a hands-on session on rCUDA, which stands for Remote CUDA. First of all, we will motivate a little the use of remote GPUs, just in case you missed yesterday's presentation of my colleague Fede. Then we will focus on the main purpose of this presentation, which is learn how to install and use rCUDA. In third place, we will move on using rCUDA over high-performance networks, in that case, Infiniband. And finally, we will see some sample scenarios in which we could take benefit from rCUDA. So let's start. Well, as you know, current high-performance clusters are heterogeneous platforms which are mainly composed by CPUs and GPUs. In the case of the latter, of the GPUs, they introduce one main advantage is that we can reduce execution time of parallel applications. In contrast, we have also several disadvantages. For example, the increasing cost. We must buy GPUs, we must maintain them. GPUs use space in my cluster, GPUs affects the cooling of my cluster, and so on. In addition, we have also that GPUs consume a lot of energy, and if we add to these disadvantages that GPUs usually have a low utilization rate, I mean it's difficult that your application is using the GPU all the time. So it could be a good idea to share some GPUs between some nodes of the cluster. This is what is called remote GPU virtualization, and consists on just having physical GPUs on some nodes of the cluster and sharing all of them or only some of them among some nodes of the cluster. Obviously, we have here the disadvantage that the remote GPU virtualization itself introduces an overhead, of course, and also we have the overhead of the network. We are not only moving data from main memory to the GPU memory, we are moving data also through the network. Okay, so when we talk about using GPUs in order to accelerate applications, we are mainly talking of two techniques, OpenShield or CUDA. In this presentation, we will focus only on CUDA. This is the general architecture for remote GPU solutions in the context of CUDA. Here we have a client which is running a CUDA application. In that client, we have substituted the original CUDA libraries, but the remote GPU virtualization libraries. These libraries will forward the CUDA application request to the server in the other side, where really the GPU where is really located the GPU and where the CUDA libraries are really working. So there exist several solutions. And during this presentation, we are focused only in the one we have developed, which is rCUDA, as I said before, and which is freely available and supports CUDA 5.5. Here is an overview of the communication architecture of rCUDA. Just focus on, we have here a specific communication module which allows us to optimize the GPU virtualization depending on the network, the overlying network we are using. For example, we have a specific communication module for Ethernet and for Infiniband. So basically, this is the scenario we have. With original CUDA, we have a node and we have a physical GPU, and with remote CUDA, we have a node with does not have a physical GPU and can use a remote GPU through the network, thanks to rCUDA. So let's move on now to the next section. Well, first of all, where do I obtain rCUDA? You just have to enter our website, rCUDA.net, and fill a software request form, and then we will send you rCUDA. Once I have rCUDA, I receive a package which has mainly two important folders. One is just documentation, similar to the information we're giving here, and the other one is the framework folder, which contains the rCUDA libraries, which will substitute the CUDA libraries in the client side, and also the rCUDA server, which will be running in the server side, only in the physical GPU. To install, we just uncharge the tarball in both the client and all the and in both the server and on the client nodes, and that's all. So let's start with the use of rCUDA. First of all, I must start a server in a node with a remote GPU, with a NVIDIA GPU. This is the same. To do that, we mainly do the same thing as if we were to run a CUDA program. That is, we export the path to the CUDA binaries, and we also export the path to the CUDA libraries. Well, then we just start the rCUDA daemon, which automatically starts in background, and that's all. Now we move to the client part. We are now in a node which does not have a GPU, so here we export also the path to the CUDA binaries, but in the case of the library, instead of exporting the path to the CUDA libraries, obviously we export the path to the rCUDA libraries. Now we must tell rCUDA how many GPUs, remote GPUs I have. This is done by environmental variables. In that case, rCUDA device count. In that case, we are telling rCUDA we have one remote GPU. And now we tell rCUDA where is that GPU, the server, and the number of the GPU of that server. One important question here, till CUDA 5.0, we don't have to do anything to our applications, but since CUDA 5.5, we have to recompile them. I mean, by default, in CUDA 5.5, CUDA programs are compiled using static libraries. We just must recompile them, indicating this extra flag, which is provided by NVIDIA, and which allows me to compile the programs using dynamic libraries. I need dynamic libraries because I want to substitute the original CUDA library by the rCUDA library in execution time. Okay, but that's recompiling with that flag. And so now let me illustrate it with a live demonstration. I'm going to connect to server in our university. So we are going to connect to two different nodes. We are going to run an NVIDIA sample, which is called bandwidth test, and we just perform a copy between main memory, and GPU memory. So first of all, we are running this sample with CUDA. For that, we export the path to the original CUDA libraries. As I have said before, we are going to run the bandwidth test with original CUDA. For that purpose, we export CUDA libraries. Okay, we are here in a host name C9, and in the other side we are in a host name C10. So we are running the bandwidth test using regular CUDA. Now yes, we have, you can see the bandwidth. Okay, now we are going to run the same, but using rCUDA. For that purpose, we just change the libraries I want to use. In that case, I want to use rCUDA. And if I try to start it now, it is going to fail because we have don't start a remote server. Okay, we must first start a server in a remote node. In that case, we must go to path, and so now, as you can see, the rCUDA server is started in background, and now we can run our test. Okay, here we have a problem, no? We have a very low bandwidth with rCUDA. So maybe let me check if I can find my slides. Okay, I will try to. I'm sorry, but we are supposed to having tried this and everything works. So now we have seen that we have a problem. The bandwidth of rCUDA in comparison with the bandwidth of CUDA is too low. This is because we are using Ethernet, the solution moving to high performance network, such as maybe Infiniband. So we are trying to do the same as before, but in that case, we are going to do it, but using Infiniband. So the only difference I have to, sorry? Yeah, maybe. Control plus. Yeah. Okay. Yeah. So but now, I think I. So now, thank you. Okay. So if we want to run the same sample but using Infiniband, we just kill the previous rCUDA daemon, and we must tell rCUDA that we want to use Infiniband. This is as simple as setting this environmental variable and restarting the server. So now we have started the server in background. In the client, the same. We must tell rCUDA we want to use Infiniband protocol, and if we run test again, now we can see we are almost there. Okay, if we compare bandwidth now, for some scenarios, we could take benefit from using rCUDA. Well, which are those scenarios? So, for example, imagine we have an application that is capable of running with a lot of GPUs. The more GPUs I have, the less execution time. So with CUDA, we will have a physical limitation. There are nodes, maybe now there are nodes, I think, with 8 GPUs, or something like that. But this is not typical. We usually have 1 GPU or maybe 4 if we are lucky. So we are going to illustrate that with a sample which is called Monte Carlo multi-GPU, and we are going to compare CUDA with a node which has 4 physical GPU, and we are going to compare this against rCUDA using 8 GPUs in 8 different remote servers. So let's try if we can do it. Here we are going to switch to another node. I have almost everything prepared. So this is the node which is going to be the client, C7, and this is the node which is going to start the servers in all remote nodes. Let me check. So first of all, we are going to start all the servers. We have a script which just connects to every server and start it. So now, as you could see, we are, and in that case, here we have the variables we have to support. Here we are just telling, okay, we have 8 GPUs. GPU 1 is in that node, GPU 2 is in that node, and so on. Okay? So now we are just, there's a command which tells you the physical GPUs you have. So this node only have 1 physical GPU, okay? But if we make a test provided by NVIDIA, which just shows you all your CUDA devices that you have access for, it will tell us that we have okay, you could see that we have one physical GPU, but we have 8 CUDA capable devices. So we are using 8 remote GPUs. So now we are going to try the sample. This is the Monte Carlo sample, as I've said before. This is running it with rCUDA. As you see, we are using 8 GPUs. In that case, 8 remote GPUs, and well, we can see here total time and real time. Well, we are going to compare this. We have a node which has, as you are going to see now, 4 GPUs, 4 physical GPUs. So we can see here GPU number 0, GPU number 1, 2, 3 K20s. Okay, we are going to run say sample. Sorry. So now we are using 4 GPUs, as you could see, 4 GPUs in that case, CUDA. So left side is CUDA, right side is rCUDA using 8 GPUs. Okay, now we are going to compare time. So here we have total time, and here we have total time when using rCUDA, and also we can see the real time. So here my application scales well, and I can take profit. The more GPUs I have, the less execution time I have. So let me show you some other scenarios. I think we are here. Okay. Other scenarios in which we can take profit from rCUDA. Typically, we have a. Sorry, I think this has moved. In a typical CUDA application, we move data from main memory to the GPU memory, and then performs there a lot of computations. Why? We want to compensate having moved data from main memory to the GPU memory. With rCUDA, this behavior matches, but we have to compensate the extra time, as I have said before, of having moved data also through the network. So typically, we will have to perform more computations in order to avoid the overhead of using a remote GPU instead a local GPU. So let's see that. In that case, we are going to see a sample with lamps. We are going to see the example. We have one node using one GPU. We are going to run lamps here, and we are going to run the same example back using a remote GPU. Note here that we cannot spend a lot of time here, but this affects rCUDA. But if the bigger we have the size of the problem, the better for rCUDA. So here we are going to see a simple sample, but so first of all, sorry. Okay, thank you. So first of all, I am going to kill all the servers I have, and now we have only one remote server, and we are going to start it So we have started the server again, and now we are moving to lamps. So here we are going to run lamps using a remote GPU. First of all, if you want, we are going to, in order to make sure we are using a remote GPU, we are going to kill the server, and we are just going to see that we cannot use, sorry, they are. So okay, this is the correct one. So as you can see, we have the same problem as before. We must start the server. This is just to confirm that we are using a remote GPU, and then we start the test. So this is the test with a remote GPU. Okay, you could see, for example, loop time 3.5. Now we are going to kill the remote server, and we are going to run it using just regular CUDA. For that, again, we just change library path to the one of CUDA, and I run the same test. This is going to take more or less 3 seconds of loop time. Here we have over 3 seconds. This is time with original CUDA. This is time with rCUDA. In that case, as I have told you, if we increment the size of the problem, for example, by setting larger variables x, y, z, we will rCUDA we will be near from CUDA. But here, for example, we can do run the same sample, but using, as you see, 12 processors and no CUDA. CUDA is off, and we can compare the time running on a CPU or against running on a remote GPU. So this is going to take almost 12 seconds. We can finish because I think we are. So it has finished yet. As you see, 12 seconds. If we compare that time with the one using a remote GPU, it's good results for rCUDA. So now, I think we can. So this is all. Thank you for your attention, and sorry for the inconvenience. And if you have any questions. Okay, thank you.